Hello, everyone, and welcome to the interview episode of What's New in Cloud FinOps with myself, Frank Contrepoix, and my great friend,
Stephen Old. Hi, Frank.
Hello. So today we are going to talk about a topic that something that everyone uses continuously.
Yeah.
It's just extremely hard then to make sense of it or use the data correctly. And we're going to talk about time series. And for that, we have Henk. Please introduce yourself.
Hi, thanks for inviting me and thanks for the opportunity to speak out about what we do. So my name is Henk de Metsenare. Sounds like a weird name, but it's a Belgian name. So I live in Belgium and I'm the co-founder and CEO of Tangent Works. And what we do is interesting, but we'll talk more about that.
Excellent.
So I mean, I understand time series to an extent. Frank actually understands it. So as the voice of the listener here, give us some, because I know you've come from time series, right? That's kind of been your background, and now you've come into the FinOps space. But tell us like a bit about time series and how you got into it and like where else it's used in the world.
Yeah, time series data is an interesting topic. Certainly, if you look at it from a machine learning and AI perspective, I mean, there's in every company there's time series data, because if you want to kind of simplify it on what that actually is, in the end, it's just numbers that evolve over time, and that can be anything. It can be sensor data from a machine. Stock exchange numbers are time series that evolve over time. And then later we'll talk more about cloud consumption data. That's also a number that evolves over time. So we come from there. And if you talk to people about time series data and then applying machine learning on that data to make sense of it, depending on who in fact, you can talk to many people like academics or people in companies, but you always get the same answer. It's always like, wow, that's the difficult problem to solve. So time series data, because of the notion of time, and we can expand a bit on that later, makes it very complicated to model. But there is a big need, because if you have time series data, there are two fundamental use cases that you can do. One is that based on your data, you make computer models to be forward-looking, so make predictions, forecasting. Or the second use case is basically that you use the same time series data, but then you make computer models to see if the data behaves normal or abnormal, and that we call anomaly detection. And if you detect anomalies, of course, you also want to understand where do they come from? What is the reason for the anomaly? You don't just want to have numbers, but you also want to have insights. And creating these computer models is the art or science, depends who you ask, of machine learning. And that's where our technology comes in. Now, you asked a little bit, Frank and Stephen, about the journey. We created this company about 10 years ago. Then it was widely, just to set the frame, there was no ChatGPT 10 years ago. The context was different. So in those days, AI and machine learning had the ambition to bring intelligence into business processes, but you had spot solutions, so a solution for different problems. Now we tend to look at more generic AI solutions, but in those days, for sure, it was not the case. And I'm quite confident that even today, with the transformer architectures that we have, time series modeling remains still a different animal, and it will still take quite some time before we can just apply generic technologies on that. So, but 10 years ago, when we looked into the problem, we got a strong confirmation of many companies that they have time series data and they want to do something with it. That's one. Two, they said, if we want to do something with it, we should bring in some level of automation to make it doable, because now we need to spend so much time from smart people, engineers that engineer these models. And we can talk a little bit more about what that means, engineering these models. And then once they have a model, they can apply it in a real life scenario. But then with time series data, the strange thing is that things change over time, right? So patterns and numbers can change over time because your business is changing. I mean, the biggest, there was a period in time where we got a lot of data sets with changing data, and that was the Corona pandemic. Yeah, companies had companies had built engineered forecasting models to predict something, but then all of a sudden the underlying patterns changed completely because of lockdowns and whatever, and all these forecasting models that worked in the past all of a sudden didn't work anymore. So you need to redo the engineering and you can start from scratch again. So basically, modeling time series data is too costly, given the fact that you need to redo it all the time. Yeah. And so the business idea that I had was we need to bring in automation. But at that point in time, I had no clue on how to do it, to be honest. But from a business perspective, I mean, I'm an engineer by education, but then I also studied economics, and that combination made that I was never really an engineer. I was more in managerial roles, but in high-tech environments. And I looked at things from a business perspective. I saw the opportunity, but had no clue how to solve it. But then later on, I worked together with a co-founder who was a PhD in mathematics. And to cut the long story short, he had an idea on how to crack this nut. Yeah, so how to bring in a certain level of automation. And if I now, in the interest of time, fast forward a couple of years of trial and error, prototype building, fine-tuning certain things, what we built after all that time and investment was, we call it an engine, where basically you send in a table with data, because time series data, you can look at it as a big Excel sheet with numbers. So it has rows and columns. That's basically what it is. The rows we call measurements. The columns are predictor candidates, data points. If you have such a data set, you send it to our technology. We do the number crunching on the fly, and I can expand a little bit on that, but we do the number crunching on the fly, which is the feature engineering out of all the data sets, all the data points that you have. You want to select those that will really help you to do what you want to achieve, make a forecast or detect anomalies. And once you have those features, you need to assemble them in a model, and then you can make either a prediction or detect anomalies. But we do that on the fly. So instead of days, sometimes weeks of engineering, we replace that with seconds, minutes of computing time in the cloud. And what you get back once you send in a task, so a table with some information, which is a task, after seconds, minutes, what you get back is a human readable model. And that is important because you want to see numbers, but you want to understand why the numbers are the way they are. So we deliver human readable models and immediately the forecast or the anomaly detection that you asked for on the fly. And just to finish on that, basically what you do is you bring the moment of model creation, engineering, if you will, together with the moment of model consumption and inference, as machine learning experts would call it. And that's interesting because by bringing them together, the time gap that is in between is gone. So if in between, and I exaggerate, a corona pandemic happens, you don't need to re-engineer your models because you make a model every time again, the moment that you need it. So if something happened in the meantime, it will already be reflected in your data, and the system will pick up that change in pattern and automatically adjust to that. Now, you asked about the journey. That was the journey. So we had the solution. When we pitched that to many companies, everybody said, wow. And then we could also show that it worked, and then the wow became even bigger. But still, to be honest and fair, growth of the company was quite limited. And that was for two reasons. One was lots of companies thought that they had high quality time series data. But then once we started doing pilot projects with them, it turned out that it was not so good. So there was a lot of work still to be done on the data quality side. I mean, we live in 2024, 2025 by now, but still a lot of companies need to work on data quality. So that for us was like they loved the technology, but they were simply not ready because their data was not ready. Their data pipelines were not ready. So that limited our growth. And then second, what we also saw in an industrial environment, because that's where we found a lot of time series data, and because of my background at Siemens in industrial automation, I had a strong link there. On those data sets, I mean, you find them in production processes, But those processes were optimized already. I mean, companies have always been busy by doing their stuff as good as they can with the technology available. And then at some point, everybody had high hopes that if you would add machine learning and AI in the equation, that things would be so much better. But we can only get out of data what is in there. We can do it in a very efficient way, but if there is no patterns in the data that add a lot of value, then you're also stuck. And we had a bit of that also. So if we found companies that had good data and good data pipelines, applying our technology delivered them very good models, but the economic value of the outcome, and it has nothing to do with the model, that has to do with their business, was quite limited. So as a company, we said, okay, we have great technology, we're applauded for that, but we don't grow the way we want to grow. What can we do? And that's what brought us to FinOps, basically. We sat together with the team and we said, we need to find an urgent growing problem where time series matters. Yeah? And that for us was the FinOps space.
Nice. Yeah, well, definitely an interesting one. Everyone talks about forecast. Everyone talks about how you take your data, you do anomaly detection, you do prediction, you see, you manage that data, which is always temporary because it's also provided as a time series from cloud vendors, hourly usually. And yet we talk about it, but very few do it correctly, or it's really hard to do. There was a talk at FinOps X, which I really liked, which was about this, and it was about which model do you use to detect what is white noise. So changes that will not change your model. You compare that with changes that would require you to do a new model. So what you're saying is you're automating that building of the model, and it's going to be valid until assumption underlying it's correct. I guess that's the. So
yeah. Mm-hmm. Yeah, correct. So I was also in that talk, so we can elaborate on that. But
yeah, I like. Oh well, yes.
But you gave a talk in the first FinOps X about forecasting, the forms forecasting.
I did, yes. I was my 10 minutes of glory. Yes, I did a talk in there, and I was also explaining how you can. Yes, models are really good, but usually it's also you have 4 or 5 ways to forecast, and when you start putting them together, you get an even better thing. And some of them are cheaper or simpler to manage, including wisdom of the crowd was part of this, is to say, if you ask to everyone who is involved, you're going to get a 10% accuracy. It might be good enough for you to start. It might be the best forecast you can get at the moment, but yeah.
I mean, I've seen organizations build out their own forecasting and basic forecasting. And I've also, I work with a lot of tooling providers, I advise them for free just because I think there are improvements that can be made. And I see them do it in the simplest way they can because it's hard, right? Yeah. You do. And it quickly becomes meaningless. Like, I'm a big fan of simple, right? And trying to keep things simple. But there are some things where simple equals meaningless. And if you are, so I used to work with an organization who worked a lot with education. So school terms, busy, then quiet, busy, and quiet. And if your forecasting data didn't look far enough back, didn't understand the differences and make that because it understood the concept of time, then it all the forecasting tools or in the standard tools that we had there at that organization at the time were just meaningless. Like, we were better off doing that horrible thing of looking at last year, increasing it by X percentage, because that was more accurate than the tools were, because they were doing, whether it's linear regression, whatever it might be, it just kept being meaningless. And you've got to have that concept of time to make it meaningful. Yeah. And that's what I've seen just lacking in general. And, it's not the world. Like, what I think is really interesting about you guys and your approach is it comes from, you come from solving this kind of problem and then come into the space. Yeah. I think, agreed. So I do a lot of maturity assessments, right? And I see 2 of the weakest areas. Well, there's a few weakest areas. Sustainability is one of them, frankly. That's a whole different ballgame. But 2 of the others are anomaly detection and forecasting, right? Because if you just switch on local anomaly detection, like standard anomaly native, you get thousands of false positives. So you have to kind of create this concept of what an anomaly means to my organization. Yes. Then you have to program something to make that happen. And really, if you understand how to use the data, that is the kind of thing that can come out of the work you guys do, right, Henk? Where you can actually, over time, make sure that an anomaly is an anomaly. Like what is being recorded and reported is doing that because you're looking at data as time. If to my understanding, is that fair?
Yeah, absolutely. So a lot of the points that you touched on was really the motivation for us to develop the system that we have, but then in another context, and is also the reason why we think it can help companies in the current context. And first of all, you touched on two use cases. They're a bit related. One is forecasting, and the other one is anomaly detection. The reason they are related, but I don't want to go deep there. If you train a model, that is, you capture patterns from the past. There's something in your data. There are hidden patterns there. The Monday can be different for some reason, so that should be in your data. We call that seasonalities that might, or then you have trends. It can go up, it can go down, but the going up can be linear, can be exponential. So time series data can go in all directions because then it can grow exponential, but you kind of add the seasonalities on top of that. And that's ultimately how a weird signal that you see, so numbers that evolve over time, behave, and you want to detect the underlying patterns and the underlying influencers, features we call it, that result in that. So that's the forecasting use case. But then the anomaly detection use case is highly related, because if you train a model on past data, and you need to trick it, you need to do a couple of things, but it's not too complicated. You could call that a normal behavior model. That's how stuff works normally. And then you can make predictions and compare them. I mean, short-term predictions, and you compare them with reality as you measure, and then you see, wow, this is the difference between what I thought it would be and what it actually is too big, and that's why we need to do something. And then you flag it as an anomaly, but then flagging it as an anomaly is useless, because then you know there's something wrong. But sometimes you can see it with the naked eye that there is something wrong if you just follow the trend line. But you need to understand why it is wrong. And then you come to the complexity of the cloud space, basically. If you look at cloud consumption, depending on which level, I mean, you need to look at your cost on a certain level. But that's always an aggregated view. Underneath, there are a lot of cloud resources that constitute this cost that you will ultimately pay. And you need to be able to look into all those things that constitute the cost in a way that you can find there which of all these things, and I mean, really, we talk about hundreds and sometimes thousands of resources that all together make out the cost, and still you need to find in those which one is now the one I need to look at. Because what you want to do, if there is a problem, you want somebody to fix it, right? So you need to send someone a message like, there is a problem, and we think that you need to look there because probably the reason is there. Now, to cut the long story short, to be able to do that, you need to do proper feature engineering. So again, we go back to this Excel table. It has rows and columns are data points. So that is like, I don't know, bandwidth, memory, whatever. Machine can be anything. You look on that level, but you don't know for this anomaly which one will contribute there. So you need to select out of these columns of data the right ones that give you the right information. And in the context of machine learning, we call that feature engineering. And in a way, that's the nut that we cracked. Yeah. So it's mathematics. It's not voodoo. But what you want to do, sometimes because it's quite. I hear you laughing, but I get that reaction a lot when I make that statement. But the reason I make that statement is, if you look at most technologies to do feature engineering, they're quite time consuming. So you need knowledge of somebody and very compute intensive, because there's a lot of things that you want to test, right? And that is where our research and that resulted in our IP helps. We do it in a different way, and and it goes so fast that sometimes when people see that, they are used to spending a lot of time and then having an algorithm spending again a lot of time, and then they know the features. And in our case, it really goes in seconds, which then allows for automation and dynamic adaptation. And they kind of cannot relate between the two. Why is it taking so much time there, and is it going so fast there? Well, that's what you get when you have the right guy with the right knowledge who spends years on trying to solve that problem and ultimately can solve that problem. But it's important that you do the feature engineering right. So out of all your data points, you select the right ones, you combine them in the right features, because that's then the information that you will require later on to have an engineer, to allow an engineer to take action. Because if you look at anomaly detection, basically, what is the basic problem that you want to solve in the cloud FinOps space? Well, something happens, you don't know about it, but then all of a sudden you get your bill and you see that your bill is different than what you wanted, right? And that's because partially, there are many reasons why that can happen, but one of the reasons is, from a technical perspective, something happened. And what is something happened? Somebody changed something to the code. There is an error there. It started to do all sorts of things that require computing time. But at that point in time, you don't know yet. You only know it when you get the bill, right? And you want to make the time frame between the moment that something happens and the moment that you know shorter. That's anomaly detection. It's nothing more, nothing less. And if you can do that, and we can do that, then you want to give as much information as possible for an engineer to take action. So who's involved in the loop? It's the FinOps manager, if you will, who wants to keep things under control. He looks at these things and he gets the right information to activate the right person to do something about it.
So you talked around the challenge of feature engineering. I have some understanding of feature engineering, so I did an AI bootcamp recently. And the fact that you're automating that, which makes a lot of sense to me, because that is hard. I'm struggling to imagine how I would do it on time series data, to your point. Is it that actually, if you learn and you master how to do feature engineering in an automated fashion for one type of time series data, that is automatically isomorphically capable of doing it with other time series data? Is it kind of because time series data follows a certain structure, you can move from industry to industry, and within reason the same technology will work?
Yeah, so basically there we go, a bit more technical. But if you look at a time series signal, you can always decompose it in some basic components. And I know I oversimplify, but I think that's good for the audience. We don't want to complicate things. But as I said, and I will go on in my simplification, you might have a signal where that goes slightly up because consumption increases over time. So there is like an upward trend. That one you need to capture. And then depending the month of the year, because summer is different than winter, maybe that can be a pattern. Then the day of the week can be a pattern. The hour of the day can be a pattern. And then, I don't know, there are certain events throughout the year or the day. If you're a commercial website, Black Friday might be something, right? So, and then you have like spikes that all of a sudden happen. So basically, it's like a limited set of things that can happen. But then if you add them up to each other, the end result is all possible signals that you can see there. But you can decompose that in a limited set. And so basically what we do, and what any engineer would do, only we found a way to automate it and to do it smarter, is you would say, okay, I have my data, I will check which of my data points contribute to achieving what I want to achieve. That's the first thing. And then the second thing you want to do is maybe I can make combinations of my data points that will still help me. But then you need to strike a balance, because if you want to do that, there's a lot of things that you potentially have to check. I gave an example that everybody can relate to. We used to do energy forecasting. Everybody understands energy consumption, and we all know if it's colder outside and more windy, that we consume more energy, right? So there is a connection between temperature and wind speed with my energy consumption that I want to predict. or if I want to detect an anomaly, it's the same. There will be a connection because it behaves normal, and then all of a sudden assume that the temperatures are average and there's not a lot of wind, but my energy consumption is very high, then maybe there's a window open. That's an anomaly, right? So, but you understand there is a connection between temperature and wind speed. But then I can also say, yeah, but the two combined might also help me. And in the jargon of that industry, they call it the wind shear factor, which is a combination of temperature and wind speed. So you will test that as well, if that helps to make your model stronger. But then you can decide, do I take wind speed of now with the wind of an hour ago, or do I take wind speed of 2 hours ago and 3 hours ago on temperature? So you get so many possibilities that you need to implement a smart way to select them right. And in an engineering approach, you will connect to the experience of the engineer. But in a cloud context, it's very complicated because there's so many underlying resources that the gut feeling might be very wrong. I mean, you can understand energy forecasting or anomaly detection, but being sure that as an expert, you will completely understand that in a cloud environment where you have so many elements that might influence it, that's nonsense. So you need to find a good way to automate that and to get the human factor almost out of the equation, because then it's more objective. And that is what we do, right? Because you need to strike a balance between accuracy at one hand and complexity at the other hand, because that would lead us too far. But you can continue to train models and train them further, and then all of a sudden they correlate everything that is in there, but you have overfitting, you go in a real life context and it's not working anymore. So you need to balance the two, and that's the technology that we bring in this field.
You brought up a kind of a concept, things like Black Friday and stuff like that. Do you see, or do you foresee organizations also overlaying some business data into this? So, for instance, if we think about online retailers, they would also have corresponding sales data that should or could be time series that they could then overlay. So you could have additional data points that help correlate. Is that something that you do, or you want to do, or you think will have value?
Good question.
Yes. Yeah, so we're like since 6 months doing the research and creating a minimum viable product where we develop or we implement. We don't have to develop the technology. It works. It's there for 10 years and it has big names that are using it in a time series context. Now we want to bring it in the cloud FinOps space. So you have a different type of user, and we want to adapt the technology or the consumption of the technology so that user can really consume it. That's why I'm saying that since 6 months we are doing the research, but it's basically talking to a lot of end users to see how they can best consume the technology. And the element that you brought on the table, Stephen, is one of them. So in our roadmap, this is part of our roadmap. So we will first do, we have that now, so you can connect to your cloud FinOps data. I mean, the focus framework helps us there because there's some sort of standardization, some sort. It's not perfect, but we're getting there. So we connect to your data and we basically start to do a first scan. We have like a starter package, a first scan, where we just scan your data for potential anomalies and we send them to you in messages so that you can already look like, based on what happened in the past, without what you just mentioned, the business data yet, but just the consumption data, what happened and can I learn something from there? But then going forward, you want to make this an operational system, and then indeed you want to complement it with what we call business context, but business context is just data. It's sales data, historical sales data, but also predictions that you want to make, and then you want to bring the two together just to make the model stronger, because there is AI and machine learning to flag anomalies. But what we also want to add to the roadmap is add AI, and there generative AI can help, add AI to the outcome. Once you see something, but again, that's a bit further on our roadmap, you can send a message to an engineer, there is that problem, but you could also install a system there where you learn what with AI, what the problem could be, and giving even better directions, or also say, yeah, we had this problem before, and that was the solution then, and these sorts of things. So later in our roadmap, So first, anomaly detection and forecasting on raw data. Then we want to add next step, but that's before the summer. I mean, there is FinOps in San Diego again. By then, we want to have this functional. You add the business context to it. And then later, you also want to add a system where you learn more based on the outcomes of historical observations.
Yeah, because there is a thing which is also that is very hard to do and is connected with all of this, which is what we call unit economics.
That's exactly what I was thinking.
Bit is to understand, because when you say, yeah, we're going to tell the right engineer what has changed, but most of the time, yes, it might not be the engineer needs to do something. It might just be the system working perfectly well and scaling as expected, just out of the boundaries. And in this case, who you need to report back to that anomaly, which might be positive, is to the exec. And they might be very happy to know that the price went up by 15% because, hey, 20% more customers or whatever the marketing campaign works. I think that's the third problem you should definitely have. Anomaly detection, forecasting, and unit economics are the three things which look simple. It's very funny. Everyone tells you it's super simple. It's like time series. Oh, yeah, it's an Excel, as you said. And then I spoke with two of the smartest people I know. For example, there was Paul. There was also Alex from a bank. And they were both saying, yeah, that's super hard. And I'm like,
Depends on your organization, right? Because there are cases where you can make it super simple. We spoke to a guy in a chalk talk, didn't we, Frank? Really lovely gentleman who said, I tried unit economics, but we couldn't find a unit. And I was just like, why have you tried to only find one? And that's part of the problem, right? It's like you can't do one, but also you can't do a million, which is probably like how far you could go. To Henk's point, you can overfit or oversimplify, and it's finding that balance in between.
Yeah. So the thing is, the history of our company was one where everybody said, wow, technology-wise, great, but we didn't explode in terms of growth because the economics were not right. So we as a company that has nothing to do with technology are now really freaks on can we prove the economic value, and then you end up with unit economics and stuff like that.
Correct.
Because we have a similar situation. When we pitch what we do, people understand time series data in itself is complicated to model, be it for forecasting or anomaly detection. People know it's complicated. They also see the extra level of complexity of the cloud space because of what we mentioned, lots of resources that kind of aggregate into the cost on a higher level. So that adds to the complexity. They also see it's a growing problem and an urgent problem. I mean, when I'm on FinOps, everybody is saying, and that's unique. There's not so many markets where you talk to people. They said, yeah, we had zero cloud spend 4 years ago, and now we have 100 million a year. And 100 million is then still not the biggest numbers that I got on my plate. So we need to manage that. All of a sudden, you have people, their attention. But what we want to avoid, and there we kind of team with the market. We have the same objective. Also for us, in terms of being successful, it's super important that we can put the finger on the economics, because we come from a space where we were also applauded, but the economics were not there. So we're laser focused on, can we prove that detecting an anomaly early on can save money, and on a level that it's significant? Because there's many areas, many means to save money in a company, and you want to save as much money with as little effort. And it's that balance that we need to get right, and that we think we can get right by doing proper anomaly detection. Yeah.
I've one more small question, because I'm conscious of time, and hopefully it is a small question. Who do you see being the customer, and by that I mean like the internal customer, the people within an organization, for the outputs of your data, of your work?
Yeah. Interesting question. And it used to be, for us, what kept us awake, but it's kind of converging to a conclusion, I would say. So in the beginning, we thought, okay, if there's something wrong and someone needs to fix it, it's some engineer who needs to do it. So we thought the persona would be the engineer. But then again, managing the finance part of the story is not his task, and it's not in their DNA. So now after lots of interaction, because in the end it's clients and the market that decides how you need to do it. All the rest is an illusion. After talking to a lot of companies that are interested in this story, we are now developing our application for the FinOps manager. So somebody who's busy with finance-related topics around the cloud, but help him to be powerful. And that means that he needs to get the information and the workflows right so he can send stuff to an engineer, and that the engineer is not saying, yeah, but I mean, you know how it goes with anomalies. The big problem is false positives, right? So if they get 10 anomalies, they look at it and the first 9 are not even anomalies. Yeah? So also there, AI can come into place to help balance the amount of false positives and true positives, because that needs to be right. And the FinOps manager will lose all his credibility and as such impact on the organization if he doesn't give the right anomalies with the right information to do something about it. So to close on that, Stephen, the question has 2 answers. A, the first person who will use the system is the FinOps guy, but he will, through our system, connect with the engineers.
Interesting. Cool. I think that was amazing. That was super interesting. And I think also our listeners have finished their, what was it? We were discussing
the workout, probably in the gym. Hopefully not their bath. Yeah.
So you're probably ending your 10K. Well done, you listener.
A good 10K time. Well done.
Yeah, well, not me. And we haven't seen the measure. Anyway, let's go there. Let's go. Thank you very much, Henk, for all
really interesting
knowledge. Really interesting, and also showing that there are solutions for those problems that we talk a lot about, or some people are working towards it. So that's really inspiring and interesting for me.
And we'll hopefully see you at FinOps X if you're going to go in San Diego. If you're saying you're going to be ready for that,
yeah,
we'll both be there. There's also FinOps X days, or whatever they're being called, the London one, April the 1st. I don't know if you're looking at that one. But there's also going to be one in Amsterdam, which is obviously a little bit closer to you as well, I think in September.
Yeah, myself or colleagues of mine will be on all those events. We're going to be with a couple of people in San Diego. Someone goes to London and someone goes to Amsterdam as well. So if people are interested, we can relate there. But ultimately, I mean, this podcast was about explaining in a certain way the complexity. So what is under the hood of the car? But what you want to have is a good car. So we want to be the company that deals with this complexity. We have the technology to do so that the user should not be worried about all the things we were just discussing. If we achieve that, then we have achieved our goal. It's about making things simple so you can focus on detecting anomalies, understanding why they are there, save cost, or make your operations better. And that's my conclusion.
Perfect.
Thank you very much. Thank you, listener.
Thanks for having me. Take care.
Thanks, everyone.
Have a great day.